In this video, we're going to go over section 1.4 from our textbook, which talks about equations of lines. And so the first equation we're going to look at is point-slope form here. So the line with slope m passing through the point x1, y1 has equation given by this here, and this is called point-slope form. So, for example, if we were asked to find the slope point form of the equation of the line given this table here, the first thing we'd want to do is find our slope. And if you remember from the last video, our equation for finding the slope is y2 minus y1 over x2 minus x1. And so all we really need to do to find the slope is just have 2 points. And we can use any 2 points from this table that we're given here. So I'm going to pick 2 of the easier ones here, or just the calculations are simple. So this means our x1, y1 is going to be 0, 3, and then our x2, y2 is going to be 1, 5. Okay. So plugging this into our equation, we're going to get 5 minus 3 over 1 minus 0. So we get 2 over 1, which is just 2, and so we find that our slope is equal to 2. And this will be true for any points that you pick, any ordered pair here. So you can pick any one and you'd get the same slope. Now what we want to do is find the slope, the point slope form of our line. So we'll start with this equation here and we'll plug in our known values. So we have y minus y1, so y minus 3, is going to equal m, and we know that m is our slope, and that's 2. So 2 times x minus x1, and our x1 is 0. Okay, so then just solving for y, we'll subtract 3 on, we'll add 3 on both sides. So we get y is equal to 2x plus 3. And this is the equation for the line, just given these points that are found on the line. All right, now if we were to graph this, we know what the slope is, and we're also given a list of values here, so we can just plug them in. So we'll get negative 1, 1, so something around there. We have 0, 3, so something around there. We have 1, 5, and 2, 7. So the line will look something like this. And then since we know the value of our slope, we can make it a little more accurate by doing the fact that our slope is equal to our rise over run. But this is just a rough sketch of what the graph will look like. All right, now we'll look at standard form. So a linear equation written in the form ax plus by is equal to c, where a, b, and c are all real numbers, is in standard form. So for example here, if we were given this example in standard form, a here is just 1, our b is negative 2, and our c is 4 in this example. And let's say we wanted to graph this. The first thing that we're going to do is find the x and y intercepts. That'll help us graph this. So if you remember from the last section, to find the y-intercept, we're going to set x is equal to 0. So we get negative 2y is equal to 4. And then dividing by negative 2 on both sides, we get that y is equal to negative 2. So then our y-intercept is going to be 0, negative 2. Right, then our x-intercept, we find this by setting our equation equal to 0. So we have x minus, we do this by setting y is equal to 0. All right, so then this whole thing goes to 0 here, so then we just get that x is equal to 4, and so our x-intercept is 4, 0. All right, The next thing we can do for this standard form is we can solve for y. And I'll show you why in a moment. So what we can do is subtract x on both sides. So we get 2y, negative 2y is equal to 4 minus x. And then solving for y, we'll divide by negative 2 on both sides. So we get y is equal to 4 minus x over negative 2. And then doing one last step of simplification, we have 4 divided by negative 2, so we get negative 2. And then we have negative x over negative 2, so that becomes a positive x over 2, or 1/2. So let's actually write this as, we have 1/2 x minus 2. All right, and the reason why we rewrote our standard form into this form is because this is now in slope-intercept form, which is what we saw in the last video, which was y is equal to mx plus b is this form. And so m, or 1/2, is our slope here. And then this negative 2 is our b, which is also known as our y-intercept. All right, and then I didn't leave myself much room. Let's move this over. This is slope-intercept form. And so now we can graph this. So we know already just by setting our x and y is equal to 0 that we have our y and x intercept here. So we can go ahead and graph that. So our y-intercept is 0, negative 2, and our x is 4, 0. So maybe somewhere around there. And then we know that our slope is 1/2, so it's rise over run. So we're going to go up 1 over 2, somewhere around there, up 1 over 2, somewhere around there, up 1 over 2, somewhere around here. All right, so then our line is going to look something like this here. All right. So now we're going to talk about parallel versus perpendicular lines. So two and non-vertical lines, so lines that aren't like this, two non-vertical lines are parallel if and only if they have the same slope. Then two lines, also non-vertical, are perpendicular if and only if their slopes have the product -1. So we're going to use these definitions in the next example. So we're asked to find the equation of the line that passes through this point and is parallel to this given line here. So if we're trying to find a line that's parallel, we immediately know that the line is going to have the same slope as this given line here, just by our definition of a parallel line. So we know that the line we're trying to find, its slope is going to be 4. Now remember, our point slope form from above, we had y minus y1 is equal to m times x minus x1. And the reason why we want to use point slope form is because we already know the slope here and we're given a point. And so the name kind of helps you out there. We have a point and we have a slope. So we can plug in our given information into this form here and get our line. So we have y minus, or y1 here is just going to be 5. And then we have m, which in this case is 4, times x minus x1, and here it is 5. All right, so then we'll distribute our 4 to both terms here. So we get y minus 5 is equal to 4x minus 20. And then solving for y, so adding 5 to both sides, we get y is equal to 4x, and then we'll have minus 20 plus 5, so then we get minus 15. All right, so that is the equation of the line that will pass through this point and will be parallel to this line. And then graphically, this is what's going on here. So our original line is the 4x minus 9 here. So that is this red line here. And then our parallel line, the 4x minus 15, is this guy here, the green line. All right. Now, let's say we're asked to find the equation of the line that passes through this point and is now perpendicular to this line here. So we're looking at the same point and the same line from the previous example, but we just want to find a new line that's actually perpendicular to this line now. So remember, our slope was equal to 4 from our last example. And by the definition of perpendicular lines, two lines will be perpendicular and if and only if their slopes have a product of -1. So if we multiply the slopes, we should get -1. So this means, let's say we have two lines with slope m1 and m2. If we were to multiply m1 by m2, their product should be equal to -1. So our first line is going to be y is equal to 4x minus 9, and that slope is 4. So we have 4 times our second slope here should be -1. So this means if we were to solve for m2, our second slope, we get -1/4. So this tells us that the slope of our second line will be -1/4. I'll call this m1. And a way to kind of remember this is to think reciprocal for perpendicular lines, but you just have to remember that we also have this negative out here. All right, then we can do the same thing we did in the previous example. We have our slope now, and we have this point here, so we're going to use our point slope form. So it'll be y minus y1, which again is going to be 5 here. Our slope is -1/4. And then we have x minus x1, which is also 5. All right, so then we get y minus 5 is equal to, we're going to distribute this -1/4 to each term here. So we get -1/4 x plus, because we have a negative times a negative, 5/4. All right, then we will add 5 to both sides. And we get y is equal to -1/4x plus 5/4 plus 5. All right, so what we want to do next is add these guys so they have to have the same denominator. So -1/4 x stays there, and then what we'll do to get the same denominator is multiply 5/1 by 4, the top and bottom. And so we get 20/4. And then 5/4 plus 20/4 is going to be 25/4. All right, and that is the equation for our line that'll pass through this point and be perpendicular to this line here. And then here is a graph of that. So this red line is our original equation, which was the 4x minus 9. And then this blue line here is our perpendicular line, this -1/4 x plus 25/4. And when it's perpendicular like this, it'll intersect our graph, or our original line, like that. All right, so that's it for this video.